today I'll be making bromine. Before we get into that, let me give you some background. My first ever chemical synthesis was making hydrogen. Now, it was not any chemical reaction, it was electrochemical. I remember I had a 100 milliliter beaker and lead graphite that you can find from mechanical pencils, and an AC/DC power supply, not even power supply, it was an adapter. And yeah, I had some wires and crocodile clips. So I made the whole setup. Then in the beaker I poured water and saturated solution of salt. I then started electrolysis. On the cathode I got hydrogen, which I collected. On the anode I had oxygen, which I did not collect. So I made hydrogen. I was really excited by this. So yeah, my next synthesis was oxygen, which was very painful to do. Not because it's difficult, it was fairly simple, just because it was very, very slow. And I mean pretty slow. My power supply, or adapter in my case, was very weak, and I didn't have anything to increase the rate of reaction, but oh well. Here you can see like a beaker, not even a beaker, container, with a little, like a drop or two of bromine. I made it by just adding hydrobromic acid to, I added perhydrol, which is 30% hydrogen peroxide, to hydrobromic acid. I barely got any bromine from that because conditions were awful. And yeah, a lot of fumes were released, and I was doing this in a balcony. So yeah, I ended up getting sick. My throat was burning, and yeah, it was painful. But after that, I had a little more successful attempts, but not really. This attempt basically gave me nothing. It just gave me more stuff to clean, and yeah. Well, from that I learned that I should have higher temperatures to increase the rate of reaction and better conditions. So what I did is I got better equipment and I started doing it. But before I got better equipment, I did electrochemical process. Well, it's pretty simple. I don't remember what was my electrolyte. It was probably hydrobromic acid, but I remember adding potassium hydroxide to keep the pH neutral. Yeah, it was potassium bromide there as well. A lot of stuff. It was a long time ago, I don't really remember. But yeah, I had a lot of hopes in this one, but it didn't work out.
So attempt, I don't know, like 10, making electrochemical bromine, electrolytic bromine. Okay, so I'm gonna use the same electrolyte that I always used. But I use a much bigger and a more powerful power supply. This is a DC power supply. So I'm running it on 4.5 volts. The reason I'm not running it any higher because it's gonna overload. And I have to turn it back and reset it. So yeah, you could already see this like reddish, part of bromine. Yeah, so this hydrogen, this if I zoom it in, you could see some bromine. Yeah. So I did not check the amperage because I don't have an ammeter, but everything is going great. See, it forms a dark layer, proving bromine. Okay, I'm going to sleep, so I'm just gonna turn it off. So yeah, things are going great. Rapidly.
Now for this one, it's me again making bromine. This was for a school science fair. I showed the difference of how bromine is forming when you add 6 or 3% hydrogen peroxide and 30% hydrogen peroxide, which is the rate of reaction. I ended up winning a mug and a pen, but yeah, it was kind of more successful than any of my other experiments. But yeah, after this one, I didn't buy anything actually. I just put off the bromine experiment for a while because I thought like I won't ever make bromine, so I just gave up on that. Before I show the clip of me making bromine, here's my setup. So this right here is a triple neck round bottom boiling flask. Triple neck, I think you understand that there are like 3 necks, one here, and one over here. So for the first one, I not even connected, I placed an addition funnel. So like, hopefully you know that on a boiling flask, like the part where you connect, the neck is like this. But the end of the addition flask is like this. So this is how it was while the experiment. So a lot of bromine fumes were able to escape. But I could not really do anything about it, so yeah. On the next one, there is a connector. I didn't draw it quite correct. Yeah. So there's a two-way, actually. So this right here is the connector. It's a two-way connector which connects the boiling flask with the condenser. And through the condenser, I'm running cold water, so bromine will be able to condense. Yeah, and on the end of the condenser, there's a receiving flask in ice water. So if you listen to anything your chemistry teacher taught you in 7th grade, then you should know that heat increases the rate of reaction. That's why I was heating the reaction. Even though it's exothermic, I was still heating it. So yeah. Then let me just play the clip of, yeah, I'll just play the clip. By the way, here is the reaction itself. Hydrobromic acid plus hydrogen peroxide. We get bromine and dihydrogen monoxide. So yeah, I'll play the clip right now. This is me setting up the whole equipment. Although I knew that almost nothing fit each other, but there was really nothing I could do. Okay, so here I'm about to add hydrogen peroxide to hydrobromic acid. You might see that hydrobromic acid is yellow, although any concentrated solution substance, for example acids, are usually colorless. Well, this hydrobromic acid is very old. Well, old, like a year and a half old. So yeah, as you can see, as soon as I add hydrogen peroxide, its color starts becoming more red. This means that bromine is starting to form. Now, since this reaction is exothermic, as you can see, I'm checking the boiling flask if it's too hot, because if it is, then I'd let it to cool down a bit, so I won't overheat it, because I'll have to heat it to increase rate of reaction. But if it's already hot, it's gonna enter state of equilibrium. So yeah, I'm just waiting for it to cool down. By the way, in some clips you might see me with a gas mask. Yeah, so that shit didn't work. Well, I'm pretty sure it's a good gas mask. It's just that it doesn't have an oxygen tank attached to it. So I only used it for eye protection, and so I would inhale a bit less bromine than I'm supposed to. Like, in ideal conditions, the gas mask is supposed to have a little oxygen tank so I could breathe. But right now I'm just breathing air, what I would breathe without the gas mask. So yeah, and as you can see, the boiling flask is starting to become more red and red. I really have nothing much to say, so just watch the clips. Absolutely no way I finally made bromine. I'm happy as hell, but my lungs are killing me. Yeah, it's bromine after a while. So yeah, that's how I made bromine. I made and sealed the ampule myself. I just took a test tube and melted the neck a bit, made it pretty thin so it will be easier to seal it afterwards. Then I poured bromine and then afterwards I sealed it. So yeah, although this was incredibly fun to make, it's still dangerous. Why? Because I'm dealing with hydrobromic acid, which is pretty dangerous. And bromine is a very toxic gas. Well, it has toxic fumes. Bromine is a liquid at room temperature, but yeah, it's also very volatile, meaning that it tends to evaporate very fast. Yeah. And I got sick 2 or 3 times when I tried to make bromine. For example, after I successfully made bromine, I also got sick. I don't know, for like 2 weeks. But yeah, if you can make bromine when you have proper equipment and especially good ventilation, because bromine can really throat and lungs. So yeah, I don't have anything else to say. If there's any experiment you'd like me to try, I will try my best to see if I can make it. So yeah, for now, goodbye.